Hello everyone, welcome to Maha EMRS e-learning project. I feel really great to deliver a lecture of a 12th standard physics through the Maha EMRS e-learning project. First, let me introduce myself. I am Mr. Sanjay Lakshman Bontawar, working as a PGT Physics in EMRS Borgaon Bazar. Today I am going to teach you Standard 12th Physics first chapter, Electric Charges and Field. And my topic name is Coulomb's law, force between 2-point charges. Let me start by giving you the introduction about some important points from our topic. First, charge. Next is the types of charge. Then electric field. And last one is the Coulomb's law. Okay, so let's start with the electric charge. Electric charge is the physical property of matter that causes it to experience a force when placed in an electromagnetic field. You can see how electric charges are interact with each other. The electric force gets stronger as the charge gets larger in magnitude or size. But note that both the charges always feel same force. The electric force gets stronger when the electric charges move closer together and gets weaker as they move farther apart. Are you getting my point? So now we have come to the properties of charge. According to the principle of conservation of charge, the charges are neither created nor destroyed. They are only transferred from one body to other. It means they are always conserved in an isolated system. Similarly, according to the principle of quantization of electric charge, all the free charges are integral multiples of basic predefined units, which we denote by E. It means electrons have charge negative and protons have charge positive. The SI unit of charge is the coulomb. 1 electron is equal to 1.6 10 to the power minus 19 coulomb. It's a magnitude. Let's move on to our next point, types of charge. All matter has electrical charges. There are two types of charges. First, positive. Second one is the negative. If you have an equal number of positive and negative charges, it is neutral. Now I would like to turn our next point, electric field. The electric force per unit charge is called as electric field. Here E is equal to Fe upon Q, where E is the electric field, Fe represents the electric force and Q is the charge. The SI unit, Newton per coulomb. Electric force is the vector quantity. It means it has magnitude as well as direction. The electric field is radially outward from a positive charge and radially towards a negative charge. You can see this in picture. The direction of field is taken to the direction of force. It will be exerts on a positive test charge. Now we are going to talking our important topic, Coulomb's law. The statement of Coulomb's law is the magnitude of electrostatic force of attraction or repulsion between 2-point charges is directly proportional to the product of magnitudes of charge and inversely proportional to the square of distance between them. The force is along straight line joining them. You can see how the electrostatic force is intact with each other in a figure. Let's look at this in more details. Let me elaborate. Consider there are two charges, Q1 and Q2. The distance between them is R and the force of attraction and repulsion between them is F. According to Coulomb's law, force is directly proportional to the mode of two charges Q1, Q2. It means force is directly proportional to the product of mode of Q1, Q2 and inversely proportional to the 1 upon R square. From equation 1 and 2, we get the third equation, that is F is directly proportional to mode of Q1, Q2 upon R square. Therefore, F is equal to K mode of Q1, Q2 upon R square. Here is the K is Coulomb's constant or proportional constant. It is not a universal constant because it is depends on medium. Therefore, K is equal to 1 upon 4 pi epsilon naught. Epsilon naught is the permittivity of free space or air. Therefore, we get the equation of Coulomb's law, that is F is equal to 1 upon 4 pi epsilon naught mode of Q1 Q2 upon R square. Now I would like to expand on my points about the Coulomb's law in vector form. The force acting can be written as force acting on second charge due to first is given by F21 is equal to 1 upon 4 pi epsilon naught Q1 Q2 R square. R cap is the unit vector and its value is R cap 12 is equal to R12 upon R12. You can see the second equation in vector form. Similarly, we get the last equation according to Newton's third law, that is bar F21 is equal to minus bar F12. Limitations of Coulomb's law. We can use the formula if the charges are static, it means in a rest position. The formula is easy to use while dealing with the charges of regular and smooth shapes, and it becomes too complex to deal with charges having irregular shapes. The formula is only valid when the solid molecules between the particles are sufficiently larger than both the charges. Now let's summarize briefly what we have looked at, we have covered in this lecture. Electric charge. It is a physical property of matter that causes it to experience a force when placed in electromagnetic field. Then types of electric charge. There are two types of charges, positive charge and negative charge. Then electric field, electric force per unit charge called as electric field. Its SI unit is Newton per coulomb and its equation Fe upon Q. And last one, our important topic is the Coulomb's law. According to Coulomb's law, the electrostatic force of attraction or repulsion is directly proportional to the mode of two charges and inversely proportional to the square of distance between them. Now we get a last equation, that is F1. F is equal to 1 upon 4 pi epsilon naught into mode Q1 Q2 upon R square. Thank you for your attention. Stay home, stay safe and do the 5.